so let's start. Sige, Jan Darrell, do you have any question already? Okay. Okay, good evening. Okay, so let's discuss kinematics in 2 dimension. Ayan. So, dati kasi, yung first lesson natin, pinag-aralan lang natin is kinematics in 1 dimension. So, nung una, purely horizontal tayo, and then yung pangalawa is purely vertical. So, yung una ay, let's say ito lang. So, we have the reference, and then yung motion lang natin, it's either going to the right or going. Okay? And then, here comes the projectile. Projectile. Free-falling objects. Na yung motion naman niya, it's either going upward or going downward. So, at one point, at a time, so kino-consider lang natin motion ng object moving horizontally or vertically. But for this lesson, we are going to take the motion of the object. Hello. Hello, ayan. Ayan, okay na? Tatanggalin ko na muna yung nakasulat. Ay, class, wait. I need to restart my computer, okay? Okay, Mark, pareho yata kami. Pareho yata kami ng mahina yung internet. Fine. Ayan, sana. Cross our fingers. So, ito na. Ayan. Okay. So, let's continue. Ayan. So, saan na ba ako? Ayan. Dun sa previous lesson natin, we're only considering the motion of a particle in a one particular dimension or direction. So the first one is along horizontal, and then the second one is along the vertical. Okay? So halimbawa, ang reference natin dito dun sa horizontal, so that means, let's say the particle is here. So it's either the object will move to the positive x-axis or it will move to the negative x-axis. Pagdating naman sa free fall, so halimbawa nandito siya, so it's either mag-move siya upward or mag-move siya downward. Okay? But for this time, sa lesson natin, okay, the object will be moving in the two dimensions simultaneously. Okay? Nag-move na siya along x, at the same time, nag-move pa siya along y. So halimbawa, yung object natin ay nandito, nung particle natin from here, nag-move siya dito. So if we will get the displacement, so displacement is this one. So pagdating niya dito, so that means the object in reference to the x and y plane, it has moved in this direction, and at the same time, nag-move siya in this dimension. So nag-move na siya along x, at the same time, nag-move pa siya along y. So habang nag-travel siya dito sa direction na to, so nag-move na siya, nagbabago na yung x dimension niya, at the same time, nagbabago yung kanyang y dimension. So pagdating niya dito, so let's say this is our final displacement, and then meron tayong final displacement. So therefore, yung ating position niya, yung position niya dito or displacement, ay meron siyang coordinates na delta x at saka delta y. Ayan. Okay? So ang ano lang dito is nagmo-move na siya along x, nagmo-move pa siya along y. So halimbawa, yung particle natin is initially nasa origin. Okay? Tapos bigla siyang nag-move to 4, 3. Ayan. So position niya to, ang R niya, R initial. So yung R final niya, naging 4, 3. So kung i-consider natin yon, so ipa-plot natin siya. Ayan. So, nag-move siya along X, 1, 2, 3, 4. And then, nag-move pa siya Y, 1, 2, 3. So, therefore, nandito yung kanyang final position. So, yung RF niya ay nasa 4, 3. So, ang initial niya ay nasa origin. So, nag-move siya dito, tapos bigla siyang napunta doon. Ayan. Okay? So, yun yung two-dimensional motion. Kasi nag-move na siya along X, at the same time, nag-move pa siya along Y. Okay. If you will go through the module, ayan. So if you will continue solving with the module, ayan sinasabi niya dito na yung instead of having delta x and delta y, we will have delta r for the displacement. Okay, and that is a combination of yung r final minus r initial. Ayan. Kaya lang yung delta r natin will also be the same as yung delta x, so the change along the x and also the change along y. Or yung r final natin will have yung x final plus y final. At yung r initial natin will be x initial plus y initial. So x initial at saka y initial. Okay? So that means if we will have our formula, yung kinematic formulas natin, okay, di ba yung formula natin is delta x or delta y is equal to VIT plus 1/2 AT squared. But this time, instead of having delta x or delta y, we will have delta r, wherein delta r natin is this one, okay, or this one. Ayan. At yung V initial natin, so will be V initial X plus V initial Y. Kasi meron na siyang dalawang dimension. At yung A natin will be AX plus AY. Ayan. AX plus AY. Kasi possible na maging two-dimensional lahat ng quantities natin sa formula, except of course with time. So time kasi is a scalar quantity. Wala naman siyang direction. O ibang dimension ng time. Okay? So hindi sila kasama sa x dimension or y dimension. Ayan. May sarili siyang dimension. Kaya, lahat ng quantities dyan, which are vectors, will have x and y at the same time. Okay? So what if given ako? Given ako. Ang velocity ay initial ay, let's say, 40 meters for x, meters per second, at sa y niya ay 50 meters per second. Ayan. Okay, so kung wala tayong placement at sinabi lang natin na yung Vx natin ay Vix and Viy ay ganyan, so baka mapag-add natin yung dalawa at magkamali tayo na magiging siyang 90 meters per second, which is not possible kasi these are vectors and these two are not on the same dimension. So we cannot add them algebraically. So kailangan natin gumawa ng paraan para hindi tayo magkamali na i-add natin sila. Okay? Kaya, kailangan kong mag-discuss ng akala ko makakaligtas ako dito, hindi pala. Okay, unit vector. So I will go back to that one later. But let's discuss this first. Ano ba ang unit vector? Okay? Ang mga unit vectors, tanggalin ko muna to. Okay? Ano ba yung mga unit vectors? Ayan. Kung makakita kayo ng mga libro at meron kayong makikitang mga sign na I hat, J hat, at saka K hat, ito ay mga unit vectors. Vectors kasi meron silang magnitude and direction. So kaya sinawag silang unit vector kasi ang magnitude nila is 1. 1 unit. Okay? At class, wala silang ibang role or use kung hindi mag-decide lang ng direction. Ayan. Pang-direction lang talaga sila. So pag nakita mo sila, automatic, alam ko ito ang direction ng ganyan. Pang-direction lang sila. Ang I hat, I kasi may hat, J may hat, K hat. Ito yung mga symbols ng unit vectors. At pag nakita nyo sila, ang I denotes the direction along X. So that means that's the horizontal dimension. Okay? At yung J is for Y. At yung K is for Z. Ayan. So pinagsama-sama ko na kasi baka ma-encounter nyo rin yung third dimension which is yung Z. So if you will plot the three-dimensional plane reference, yan, obvious naman, alam nyo yan, nandito yung X, pero pagdating sa unit vector, yung X natin ay nagiging I hat. Okay? Tapos nandito yung negative I hat. Pagpataas, positive J hat. Pagpababa, negative J hat. Okay, nasaan yung K hat or Z axis? So since you are looking at the paper, three-dimensional kasi yan. Kung perpendicular siya sa inyo, saan ba? Ayan. Ayan. Okay? Yung dimension na moving towards you, nag-ano pa mo siya, nag-blur yung malayo. yung direction na moving towards you is the z-axis or the positive z-axis. Or that means that is the y positive k direction. Okay? So it's something moving towards you. That's the third dimension. Thickness na towards you. Okay? Pag yung something naman moving away from you, palayo sa inyo, so that is the negative z-axis. Ayan. Negative z-axis. So, kung di ba kung nag-AutoCAD na kayo, nakita nyo na yung z-axis. Paano ba yung drawing niya? Pag ganyan ba? Ayan. So, kumari yan yun. At ito yung papunta sa inyo. So, that's a positive k hat. At ito yung palayo sa inyo, yung negative k hat. Okay? Yes, John Darrell. Truth. Yeah. That's the ano. Pang three-dimensional. Yung K, yun yung pang third dimension, yung thickness. Okay? Yung I is for horizontal, J is for vertical, and Z is for the thickness, or that's the third dimension, which is moving towards you or moving away from you. Okay? So, halimbawa, meron akong displacement na 4 plus 3. 4 yung X and then 3 yung Y. Siyempre, hindi ko naman pwedeng isulat na ganyan. Nakakalito, baka sabihin niya 7. Kaya lalagyan natin siya ng I hat and J hat. So, ibig sabihin, yung motion ng displacement natin from X is in terms of X is 4 units. And then sa Y naman is 3 units. So, kung ipa-plot natin yan, so 1, 2, 3, and 4. So, that is 4 positive kasi, 4. And then yung J natin positive pataas. So, 1, 2, 3. So, ibig sabihin yan, nandito yung R natin na final na 4, 3. Ayan. So, we can write it as that one. O yan, hindi pwede ba natin silang pag-add niyan? Hindi, kasi sa algebra, pag hindi sila like terms, hindi natin sila pwedeng i-add. So, parang yan ang nagiging purpose ng mga unit vector. Pang direction. So, nag-move dito along 4 units along X, at the same time, nag-move siya ng 3 units along Y. Okay? May question? Okay, what if naman gusto nating kunin yung magnitude. Mali. So, dapat, I will use green. So, gusto nating kunin yung magnitude ng ating displacement. So, yan. So, initial niya, so yung final. So, gusto nating kunin yung magnitude ng displacement natin. So, kung magnitude ang pag-uusapan, so that means this will form a right triangle, pang Pythagorean theorem. So, yung magnitude ng R is equal to, okay, so that is X squared plus Y squared. Ayan. Kung theta naman ang pag-uusapan yung direction, so this one, that's the inverse tangent of Y over X, or the arctangent of Y over X. Ayan, magnitude and direction. Okay, kung mabalik ako sa velocity natin. Ayan, para hindi ako malito na yung velocity niyan. So, yung velocity natin ay meron siyang x component na 40 and then meron siyang y component na 50. So, hindi na natin siya pwedeng i-add. Okay? Kung gusto natin kunin yung magnitude ng velocity din, we'll have the square root of 40 squared plus 50 squared. Kung gusto natin kunin ang direction ng velocity, so that's arctangent of 50 over 40. Ayan. Ganon din pagdating sa acceleration. So, ganon din pagdating sa final velocity. At saka, of course, sa displacement. Okay? Kaya, yan lang naman ang role ng unit vectors. Pag-denote sila ng direction. Okay? May question? Okay, so let's have an example. Example tayo. Ayan, in terms of, I will just leave this to you to read. Ayan, just to read. And then, so let's have our example. Okay, example number 1. Ayan, a particle moves in the x and y planes starting from the origin at t is equal to 0. So if we have the particle, ayan, so initially nasa origin daw siya. Ayan. Okay, so at time is equal to 0, nasa origin siya. And it has an initial velocity of having an x component of 20 meters per second and a y component of negative 15 meters per second. So, ano ba yung given? So, we're given that the initial velocity daw along x is 20 meters per second and the initial velocity along y is negative 15 meters per second. So if we will write the initial velocity as a single equation, so therefore, so that's equal to, since x yan, lalagyan lang natin siya ng I hat minus 15j hat meters per second. So ito yung ating initial velocity. Okay. Next. The particle experiences an acceleration in the x direction given by ax is equal to 4 meters per second. So we are given that ax is 4 meters per second squared and ay is not given, it's 0. So therefore the acceleration is equal to 4I plus 0j meters per second squared. Okay? Ang given lang is purely x. That means it's only accelerating along x. It's not accelerating along y. Okay? So, ang tanong, una, determine the velocity, total velocity vector at any time t. So, letter A. So, what is V final at any time t? We're looking for the equation. So, given tayo ng V initial and acceleration, so therefore, V final is V initial plus AT. So, ang gagawin natin, substitute lang natin. So, V final is 20I is equal to 20I minus 15J plus 4I hat plus 0J hat times T. And then simplify lang natin. So V final is 20I hat minus 15J hat plus 40I hat plus 0. Huwag lang susulat. Or pwede natin pagsamahin yung may I hat. So V final then is 20 plus 40 I hat minus 15J hat meters per second. So this is our answer for A. At any time t, so that's the formula for the final velocity. Okay. Question? So given po ba yung VIX, VIY, ASMAY? Yes, they were given. Yeah. Aaron, yeah, that's a problem. The initial velocity has x component of 20, y component of negative 15, and the acceleration is purely x, so which is at 4 meters per second squared. AY is not given, so it is assumed ay 0 kasi ang sabi lang sa problem, the particle is only experiencing an acceleration in the x direction. So no acceleration along y. Okay. Let's proceed to B. Okay, class. So ito yung hahanapin. Calculate the velocity, speed, velocity and speed at t is equal to 5 seconds. So yun muna yung solve natin. Okay, given tayo ng t, so we need to find the velocity. So we'll be using this formula. So V final is equal to 20 plus 4 times 5 I hat minus 15J hat. So what's our final velocity? So that is 40 I hat minus 15J hat meters per second. Ayan. So ito yung ating velocity. Ayan. Ngayon, paano naman ang speed? Okay, remember, speed is the magnitude of the velocity. Okay, so to get speed, So the magnitude of the velocity is equal to the square root of 40 squared plus negative 15 squared. So that's equal to, not sure. So what's the answer? Ayan. So the answer is 42.72 meters per second. Ayan. So ito yung ating speed. Okay? So that's our speed. Okay. Next. As part of letter B, so ang tinatanong is the angle between the vector, velocity vector, mixed with the x-axis. So if you will plot the velocity, ayan. So yung x niya ay 40. So 1, 2, 3, 4. So let's say it's 10 each. And then negative 15. So 1, 2. So kalahati. So nandito yung ating final velocity. So, yung magnitude niya is ito. So, ito yung kanyang speed. Ayan. So, ang hinahanap natin ay theta. Ayan. So, hinahanap natin ay theta. Kung theta yon, so therefore, 40 ito. And then ito ay 15. So, kukunin natin ng theta, mag-arc tangent tayo. So, theta is equal to arc tangent of the opposite over adjacent. So, arc tangent theta is again 20.56 seconds. Degrees. Degrees. Ayan. 20.56 degrees. Okay, class. Take note ha. Ang tinatanong sa letter B is the angle the velocity makes with the x-axis. It's not the direction. Kasi kung direction yung kukunin natin, syempre mali ito dahil kung positive yan, dapat nasa first quadrant. And we should not be using 15. So we should be using negative 15 instead. Okay? Since ang tinatanong lang naman ay angle it makes with the x-axis, kaya diniretso lang natin siya based on sa triangle na nakikita natin. But remember, that is not the direction. Direction is different from the angle it makes with the x-axis. Sometimes they're the same, pero huwag nyo laging i-assume na ganon. Okay? Ang tinatanong lang kasi is the angle it makes with the x-axis, not the direction. Kung direction ang tinatanong, of course, ang sagot natin dapat ay negative 20 kasi nasa fourth quadrant siya and the direction, ang motion ng angle natin is clockwise. Di ba pag clockwise, negative yung angle. O, kaya lang hindi naman yun yung tinatanong. Tinatanong is angle it makes lang, not the direction. Okay? Don't assume lagi na ganyan yung gagawin. Okay, nasa problem lang kasi. Ayan. So, kung wala kayong question, we'll proceed to the third one. Ayan. So, letter C. Determine the x and y coordinates of the particle at any time t and its position vector at this time. Okay. So, yung una, yung x, gagawin nating delta x at any time t. So, formula natin is delta x is VIXT plus 1/2 AX t squared. Okay, so let's go back to the given. Ayan. Okay. So we're looking for delta x. What is VIX? VIX is the x component of the velocity, which is 20. So we'll write 20t plus 1/2. How about AX? Ang AX natin is the x component of the acceleration, which is 4 times t squared. So therefore, delta x is 20t plus 2t squared. So this is for the x coordinate. Ayan. Okay, how about for y coordinate? So that's delta y in terms of t. So delta y is equal to VIYT plus 1/2 AYT squared. So delta y is, what's VIY? So it's given, VIY, the y component of the initial velocity, that's negative 15t plus 1/2 AIY is 0 t squared. So this will be equal to 0. So therefore, delta y is negative 15t meters. Ayan. So meter din ito. Ayan. Okay? Okay. And the last one is yung position vector. So that's delta r. So ang gagawin lang natin is add natin yung x, lagyan natin ng I hat, plus delta y, lagyan natin siya ng j hat. So delta r is equal to quantity. 20t plus 2t squared I hat plus, hindi pala plus, minus 15t j hat meters. So this is our final answer. Yan. Okay, so that's our final answer. My question? Okay, wala. Okay, so let's continue. Okay, so that's an example of a random two-dimensional motion. Now, let's have the example on projectile. Kasi projectile is under two-dimensional motion. Ang projectile ay two-dimensional siya na ayan, nag-move na siya along X. At the same time, nag-move siya along Y. Okay? Okay. So let's continue reading this one. So a projectile is an object upon which the only force acting is gravity. Okay, the only force acting is gravity. Okay, class. This is very important. The only force acting in projectile motion without the air resistance is gravity. So kung isipin natin, similar siya sa free-falling bodies. Kasi sa free-falling bodies, kahit puro vertical yon, the only force acting on it is gravity. Okay? So later, don't forget that it has a relation. So we'll connect everything later. Yeah. So it is the motion of an object thrown on, projected into the air, subject to only the acceleration due to gravity. When we look at objects that move in both the x and y direction simultaneously, which are under constant acceleration. So this is an important special case of this two-dimensional motion. It is an important case kasi class, it's moving under a constant acceleration. So when we say constant acceleration, okay, class, so that means if projectile is under constant acceleration, which is due to gravity, it will still be applicable if to use yung mga 4 formulas of kinematics. Because the only way to use those 4 formulas is for the acceleration to be constant. If acceleration is not constant, we cannot use those 4 formulas. And since projectile is under a constant acceleration, that means we can use those formulas again. Okay? Again. So that's very important. Ayan. So the most important experimental fact about projectile motion in 2 dimensions is that horizontal and vertical motions are completely independent of each other. So that is very, very important to note, class, na yung horizontal and vertical motions are independent of each other. So the analysis is different between X and Y. So we are trying to separate the analysis for both X and Y because they are independent of each other. Though they have a common note, or later we will see. Meron silang isang common, but generally, they are independent of each other. So the analysis is different from X and it is different from Y. Kaya sinabi niyang they are completely independent from each other. Okay, so I will let you just read the remaining notes doon. I-discuss ko na lang in my own way what projectile motion is. Okay, so let's begin. So let's say we have a ball, ayan, so na object, which is at the ground. So level yan, so magka-level. And then, para magkaroon siya ng trajectory na ganyan, so kailangan, lalagyan natin siya ng velocity. So yung velocity niya is ito, so lalagyan natin siya ng initial velocity. At the same time, so since meron siyang initial velocity, meron siyang angle of projection theta. Okay, so habang nag-move siya sa path niya, so that means yung velocity natin is always tangent to the path taken. So, nagkakaroon siya ng velocity dito. Pagdating dun sa pinakataas, so meron din pa rin siyang velocity. Pagdating din ulit dito, so magkakaroon siya ng velocity bababa. Ayan. Pagdating dito, meron pa rin siyang velocity. Tangent pa rin siya sa path taken. Okay? Ayan. Since two-dimensional yan, so that means nagkakaroon din tayo ng reference. So ang reference natin is laging yung ating initial point. So laging ginagawa nating reference yung initial point. Ayan. So nandito yung Y at nandito yung X. Ayan. X and Y. Ayan. So X and Y, reference. Ayan. Okay, so mamaya gagamitin natin yan in terms of displacement. Ayan. So kung i-analyze natin, kung ito ay isang vector at meron siyang direction, so that means we can transform it into its components then. So meron ding component yung initial velocity. So ito yung kanyang VIY kasi vertical. Ito naman yung kanyang VIX. Pagdating dito, so syempre meron din siyang VY at meron din siya ditong VX. Siyempre dito, meron din siyang VIY at meron din siyang VX. So dito, meron din siyang VY, pababa na, tapos meron siyang VX. Dito din, so meron siyang VX at meron din siyang VY. Ayan. Since, okay, yung angle din nagpapalit, siyempre nagpapalit kasi yung velocity. So, di ba alam natin, pag tumatas yung isang object, okay, bumabagal siya. So, syempre, nagbabago din yung kanyang velocity, pati na yung direction niya, at saka yung magnitude. So, yan yung nangyayari sa velocity habang nagta-travel yung object natin sa kanyang trajectory. Okay? Let's focus on the initial velocity. Initial velocity. Okay, so let's focus dito. So, nakikita natin dyan na ito yung ating initial velocity. Tapos meron siyang angle. So nandito yung VIX. Tapos nandito yung VIY. So parang pwede nating i-move na nandito yung VIY. Kaya kung given yung VI, gusto nating kunin yung VIX at saka VIY. Ayan, by Pythagorean theorem. So katawa, ang cosine theta is equal to adjacent over the hypotenuse. So therefore, VIX is equal to VI cosine theta. Pag sa sine naman, so that's equal to VIY over VI. So therefore, VIY is equal to VI sine theta. And kung given naman itong dalawa at gusto natin kunin ang magnitude ng ating velocity, so that's equal to the square root of VIX squared plus VIY squared. Kung gusto natin kunin yung angle of projection, So that is the inverse tangent of VIY over VIX. Ayan. Okay? So yan ay para sa velocity. Okay, so ano ba? Gusto kong kunin. Ano yung velocity niya dito? So kailangan kunin ko yung VX dito at saka yung V final dito. VY dito. And then I perform this formula. So it also applies for final velocity. Okay? It also applies for final velocity. Same lang naman. Papalitan lang naman natin yung subscript na I na F for final. Okay? Okay, let's go to the analysis. Okay, paano ba natin siya i-analyze? Okay, class, ang analysis natin is, sabi kasi, they are completely independent. So, hatiin natin siya in terms of delta X and in terms of delta Y. Ayan. Okay, so ang formula natin gagamitin is delta X is VIXT plus 1/2 AX T squared. And delta Y is equal to VIYT plus 1/2 AY T squared. Ayan. Okay. Question. Ano ang acceleration along X? Okay? Based doon sa nasabi natin kanina, okay, saan lang nag-accelerate yung projectile motion natin? Okay, based on sa module, ang acceleration niya is only due to gravity because the only force acting on it without air resistance is gravity. So therefore, the acceleration is always going downward, which is along the Y. Okay, kung sa Y lang siya nag-accelerate, so therefore, yung AX natin is, James, it is 0. Okay, it's 0. If that's the case, therefore, this one is also 0. And delta X then is just VIXT. So this is the only formula we'll be using in analyzing delta X motion of the projectile. Nag-iisa lang siya. Ito lang. Pero ang alam natin na yung VIX is VI cosine theta. Don't forget that. VIX is equal to VI cosine theta. Okay? Next, how about what's the value of AY? Okay, so tama ka, Darwin. Okay. Okay. Since, di ba na-mention kanina that the only force acting on it is gravity and it is accelerating only due to gravity. So that's 9.8 meters per second squared. So therefore, AY is equal to negative G. Okay, class. So that means, what can we conclude about delta Y or the Y component of the projectile? Di ba pareho lang sila ng free-falling body? So that means you treat it as a freely falling body. Kung paano yung analysis natin sa freely falling body is the same analysis for the delta Y of the projectile motion. Parang free fall lang ito na nag-add ka ng delta X is equal to VIXT. So parang ganun lang siya. Okay? Ayan. So meron na tayong displacement. So meron na tayong displacement for delta X and delta Y. Ayan. Pagsasamahin po ba yan pag magsagot na, sir? Yeah, depende sa requirement. Depende. Minsan pinagsasama, minsan hindi. Minsan hindi. Madalas hindi. Okay. Depende lang sa requirement. Okay. So we're done with delta x and delta y. Now let's go to V initial. Meron tayong V initial. Ang V initial natin sa y is equal to VI sine theta. Don't forget that. Okay. Now let's go to the final velocity. Ayan. So let's go to the final velocity. Okay, class. Dito, ano ang final velocity along x? What do you think? Okay, since acceleration is 0, that means velocity is not changing along x. So V final x is the same as V initial x. Hindi nagbabago yung velocity, x component ng velocity ng projectile. Kasi hindi naman siya nag-accelerate along x. Nag-accelerate lang siya along y. And since tinitreat natin na FFB, yung delta y or a freely falling body, so yung mga final velocity, gagamitin lang natin yung remaining formula. And V final y squared is equal to V initial y squared plus 2ay delta y. Ayan. Kasi tinitreat lang natin siya as a freely falling object. Okay? So, kung final velocity pag-usapan, kayo nang bahala dyan. And then, kung gusto natin kunin ang magnitude ng final velocity, so that's the square root of V final x squared plus V final y squared. Ayan. Gusto natin kunin ang direction, so that's arctangent of V final y over V final x. Ayan. Okay? Ayan. So, di ba sabi kanina, yung horizontal and vertical components are completely different. Tama ba? Okay, saan lang sila na-relate? So, nare-relate lang sila sa time. Okay? Pwede lang natin silang i-connect through time. Ayan. Time lang. Kaya klase, minsan pag ang analysis is nauna ka dito, ang nakukuha mo lang dito para i-relate mo doon is time. Kasi nagpapareho lang sila sa time. So, halimbawa, babalik ako dito. Kung gusto kong kunin, ano yung displacement niya dito? Okay? Okay? Siyempre, habang nag-move na siya horizontally para makarating doon, so nag-move din siya vertically para makarating siya doon. So, ito niyan, let's say, so that's delta x and delta y with the same time. With the same time. With the same time. At kung gusto natin kunin, ano yung displacement niya, magnitude ng displacement, so mula dito, kunin lang natin yon. Nakikita nyo ba ang ball pen ko? Parang hindi. Sinadya ko yan. Ayan. So that's the magnitude of our displacement. Okay? So nagmumove ito ang delta y at ito yung delta x. Di mo nakikita. So ito yung delta y at nandito yung delta x. At nag-move sila at the same time. So yung time niya para makapunta siya dito along y, it's the same time para makapunta siya dito along x. Kaya, nare-relate lang natin sila in terms of time. Okay? In terms of time. May question? Oh, sige. Last na lang. Magdi-discuss lang ako ng property ng isang projectile. So let's have the trajectory and some property. So di ba ang sabi kanina, the trajectory is parabolic. Kaya pag kinuha natin yung equation ng isang trajectory ng isang projectile, so makakuha tayo ng isang parabola. Okay? Parabola. So alam niyo naman ang parabola. Okay, so ulitin ko lang. So halimbawa nandito yung V initial, and then we have VIY, and then we have the VIX. So, nandito yung theta natin. So, meron tayong dalawang may importanteng property dito. So, una yung kanyang maximum height. Okay, so tatawagin natin yung age. So, that is max height. And yung kanyang tinatawag na range. Ayan. R. R for range. Ayan. Okay? So, i-derive lang natin yung formulang, dalawang formulang ito para shortcut. So, in case pinapahanap maximum height or yung range. Sige. Ayan. Okay. At the maximum height ng projectile, anong mako-conclude natin? At the maximum height dito, so what can we conclude? That the velocity is equal to okay. Okay, so class, ito, susulat ko na. At maximum height, the final velocity along y is 0. But the final velocity along x is equal to the initial velocity. Tama ba? Yung y lang yung magze-0. So kung babalik tayo dun sa sa figure, ayan. Kasi hindi posible na pag nag-0 yung final velocity dito, na pupunta pa siya dito. Kung pati yung x is 0 natin. So yung y lang yung 0. Kung kasi pati yung x is 0, mahuhulog na siya dire-diretso dito. Dire-diretso na siyang ganyan. Kaya nagkakaroon pa siya ng path dito kasi kagagawan yon ng x. Dahil nagta-travel siya horizontally hanggang dito. Okay? Kaya yung final velocity at the maximum height is not equal to 0 but is equal to Vx. Okay? Vx. Ayan. So let's compute for the maximum height. So therefore, ang V final y squared is V initial y squared plus 2ay delta y. But V final is 0. So delta y is equal to negative VIy squared over 2ay. But ay is equal to negative g and VIy is equal to VI sine theta. So therefore, delta y is equal to negative VI squared sine squared theta over 2 negative g. Cancel natin yung negative. So the maximum height is at VI squared sine squared theta over 2g. So you can get or you can use this formula directly if you want to get the maximum height. Ayan. So pwede na yan gamitin directly. Okay? Now let's go to the range. Okay, class. Ang range is only possible pag magka-level yung initial and final. Dapat magka-level yung initial and final. So kung hindi magka-level yung initial and final, hindi natin pwedeng gamitin yung formula na to. Since x in terms yung range, so therefore delta x is equal to VIXT. Kaya lang may problema tayo dun sa time. Okay? So saan natin kukunin yung time? So kukunin natin ng time sa V final y is equal to V initial y plus AYT. Ayan. At ang time natin ay equal siya sa V final y minus, tinranspose ko yon, tapos dinivide ko ng AY. Ayan. Okay? Kaya lang, class, anong meron dito sa dito tsaka dito? Okay, di ba pag y ang pinag-uusapan, so that means kung meron kang v final x dito at saka v final y dito at magka-same level sila, same level ng initial, so therefore, di ba sabi natin, discuss natin siya sa free-falling body, na yung magnitude ng v final y ay equal siya sa magnitude ng v initial y. Opposite lang yung direction. So same yung magnitude nito tsaka to, but opposite in direction. So therefore, ang v final y natin ay equal siya sa negative v i y. So lagyan mo lang ng negative yung vi, pagpapareho na sila ng v final x. So substitute natin siya dito. So time then will be negative VIY minus VIY all over AY. Or T is equal to negative 2 VIY over AY. Ayan. At yung ngayon, ang isa-substitute natin dito. Ayan. Isa-substitute natin siya dito sa delta X is equal to VIXT. So therefore, delta X is equal to VIX times negative 2 VIY over AY. Over AY. Okay? But AY, again, is equal to negative G. And then VIX and VIY, so these are equal to VI cosine theta times negative 2 VI sine theta all over negative G. Cancel yung negative. So delta X is equal to VI squared 2 sine theta cosine theta over G. But this is a identity. It's a double angle of sine. So therefore, delta X or the range is equal to VI squared sine 2 theta over G. So this is our final answer or the formula for range. Ayan. Okay, class. But be careful. This is not applicable to any type of projectile motion. Okay? So, halimbawa, ang projectile mo ay paganyan. Tumalon siya sa cliff na horizontally yung motion niya. So, hindi po pwedeng sabihin mo na ito yung range and you will use that formula. It's wrong. So, dapat magka-level sila. So, same din. Halimbawa, ganyan. Taas naman. So, yan. So, hindi mo pwedeng sabihin na ito ay yung range. Mali. Ang range na to, magagamit lang kung magka-level. So, that means ito lang yung range. Hanapin mo pa kung anong nangyari dito. Okay? At yung isa pa, baliktad naman, pababa siya, nasa baba siya, tapos itatas mo siyang ganyan. Okay? So, hindi mo rin pwedeng sabihin na ito yung range. Hindi po pwede kasi hindi naman sila magka-level. Ang range dapat sosobra siya hanggang doon. Okay? Kaya pwede lang itong gamitin kung magkapantay yung initial at saka yung final. Okay? Any question? Wala kayong question? Hindi, mag-example na tayo. Ayan. So, while waiting for my example, kaya muna akong ipapa-poll sa inyo. While waiting for that, Ayan. May class. Ano lang, magpapa-poll lang tayo. So these are the choices. And then, you wait for my question. Ayan. So, ang question ay, ito, mag-drawing muna ako. So, meron daw isang gunman. So, nasa malawak siyang horizontal plane. Ayan, malawak. Ayan, without air resistance. So, nakatayo siya sa gitna. Ayan. Stickman. And then, sa isang kamay niya, may hawak siyang barel. Ayan. Sa kabila, meron lang siyang hawak na bullet. So, yung bullet sa gun, and then bullet lang sa hand. Okay, same level. So let's call this bullet 1, and then let's call this bullet 2. Okay, bullet 1 and bullet 2. Okay? And then, ang gagawin niya ay sabay. Sabay niya itong ipa-fire, at the same time, sabay niya din itong ihuhulog. So ito yung hulog niyang paganyan, tapos ito, sabay niyang ipa-fire. Siyempre, ipa-fire niya. So wala siyang malawak yan. Ayan. At sometimes, siyempre, mahuhulog siya. Ayan. Ang question ay, anong bullet ang unang babagsak sa lupa? Bullet 1 or bullet 2? Bullet 1 or bullet 2? Ang unang babagsak sa lupa. Okay, ang sabi ng nakakarami ay di pa sila tapos yung iba. Mas madami ang sumagot na 1. 1. Both. 2. 1. Okay. So, may tie tayo. Tie ang bullet 1 and both. Ito na yung sagot. Wala bang magbe-break ng tie? Andy, Christian, John, Marion, and Russell, what will you choose? Why are not choosing yet? Are you there? Are you eating? Are you eating? Ayun. Andy McDonald. Are you there? Okay. So, ang sagot ay 14 ang nagsabing bullet 1, 5 ang nagsabing bullet 2, and 14 din ang nagsabing both. Sandali. Sino nag-message? Si... No, yeah, yes. Darrell, I mentioned that. Ano ba sagot mo, Darrell? Oh, I mentioned that. No air resistance. Okay. So, class. Ano ba ang acceleration ng 1? Diba, acceleration ng 1 is due to gravity downward. Okay? Ano acceleration ng 2? It's also due to gravity downward. Okay. So, since pareho lang silang nag-accelerate na pababa, ang difference lang is yung bullet 2, nagmo-move siya horizontally, pero bumababa rin siya. Ang problema nga lang, bumababa siya, pero palayo siya ng palayo. Okay? So therefore, since ang tanong is, sino unang mababagsak sa lupa, syempre, sabay silang babagsak. Okay, so the answer is both. Because they have the same acceleration. Okay? They have the same we cannot do the demo. So normally when I discuss this in face-to-face class, dinedemo ko to. Kaya lang, dahil hindi ko siya pwedeng i-demo, ayun, niwala ko na lang sa inyo na sabay sila. Pag nag-face-to-face tayo, we will try that one. Or in the laboratory, you can try that. But now, we cannot try it. Sir, pwede po yung rock tsaka feather po. Magbid ako. John Darrell, we will be discussing that in Newton's law. Yeah, you're correct. Sabay sila babagsak sa lupa kung walang air resistance. Even the same identical paper, kung walang air resistance, sabay pa rin sila. Yung isa crumpled, yung isa hindi. So sabay pa rin naman sila. O nagkakaroon lang ng problema pag nagkakaroon ng air resistance. O. O sige na, ito na sa next example natin. Sa example natin. Walang ganyan. Nako. Sabi nila, totoo to. Thoughts become things. Kung ano yung iniisip mo, yun yung mangyayari. Bahala kayo. The universe might grant it to you. Yan. Tama yan. Yan. Why not, Charles? The bid. Why not the bid? Okay, so let's go to this example. Okay, so John kicks the ball, and the ball does projectile motion with an angle of 50 degrees to the horizontal. Its initial velocity is 10 meters per second. Okay, find A, what is the maximum height it can reach? B, the horizontal displacement. And C, the total time required for this motion. So, kung ito yung projectile motion natin, ito yung bola, and then, sinipa siya, ayan. So, yung velocity na pagkakasipa niya ay 10 meters per second. At ang angle ay 50 degrees. So, unang tanong, ano yung kanyang maximum height? Okay, letter A. Ayan. Should we use the shortcut? Or not? What do you think? Okay, so we can use the shortcut. Okay, so yung maximum height is equal to VI squared sine squared theta over 2G. So that's equal to 10 squared times sine 50 squared over 2 times 9.8. So what is the maximum height? Okay. So tama ba ako? 2.99 meters. Okay? Tama ba? Ayan. So B, okay, pagdating sa B, what is the horizontal displacement? So the horizontal displacement is this one. Okay, mula dito hanggang doon. Ayan. So that's our delta x. Okay, we can actually use the formula, no? Kasi range ang tinatanong na VI squared sine 2 theta over G. So that's equal to 10 squared times sine 2 times 50 all over 9.8. So what's our range? So range is 10.05 meters. 10.05 meters. Ayan. Okay? 10.05 meters. Okay. Letter C. What's the time? Ayan. Okay, class. Ngayon, based on sa analysis, saan natin siya mas madaling kunin? Sa delta x or sa delta y? Siyempre, ang tatanungin dun sa delta x. Kasi delta x is VI xt lang. So that means, yung time natin is delta x over VIX. Question ay, meron ba tayong delta x pagdating dito? Okay, so na-compute natin yung range. So that means delta x is also the range na 10.05 meters over yung initial velocity na 10 times cosine 50. So what is the total time? Okay, 1.56 seconds. Ayan. 1.56 seconds. Okay? Or we can use another formula. So, or we can use another method. So, or gusto nyo siya sa delta y is equal to VIYT plus 1 half AYT squared. So, that's the same. Kaya lang, pag delta y yan, so anong Okay, okay class. Ayun. Ayun na naman. Nawala. Na-disconnect na naman ako. Ay, nako. Patatapos na lang tayo, mawawalan pa ako ng connection. Ayan. So, bibilisan ko na lang dahil time na. Ayan. So, therefore, yung time dito ay equal siya sa negative 2 VIY over AY. So, that's time is equal to negative 2 times 10 sine 50 all over negative 9.8. So, the time is still 1.56 seconds. Ayan. Okay? Or you can also use another formula. Pwedeng yung V final Y is initial Y plus 80. So it's up to you. So which formula you want to use? Solve for time, but the answer will remain the same. Okay? Sayang hindi ko na mapapakita yung shortcut. So can I just use yung sinolve ko kanina para yan, yung shortcut. Okay, so gagamitin ko na lang yung sinolve ko kanina to show you the shortcut method, which is very powerful in solving projectile motion. So I am using this formula a lot because it's very useful. Ayan, so I'll just explain it. Ayan, okay, so sinolve ko na siya kanina kasi. So ito yung shorter form. So sa board exam kasi, ginagamit ito na shortcut para ma-solve ng mabilis ang mga projectile motion. So kung titingnan natin in terms of displacement, so ito yung displacement along X, and then itong displacement along Y. Okay? Di ba sabi rin natin kanina na connected sila in terms of time. So kunin natin ng time with respect to delta X, so ito yon, and then isa-substitute natin siya doon. Okay, pag sinubstitute natin, so we will have delta Y is equal to VIY times T, which is this one, plus 1/2 times AY times delta X over VIX squared. And then we'll just simplify. But VIY is equal to VI sine theta, delta X over VI cosine theta. So we can cancel VI plus 1/2 AY times delta X squared over VI squared cosine squared theta. So therefore, the general formula of a projectile is equal to this one. Ayan. So delta Y is delta X tangent theta plus AY times delta xy over 2 times di squared cosine 2 theta. So halos lahat ng projectile motion is kaya niyang isolve ng formulang ito. Very easy. Ayan. So hindi mo na kailangan kumuha ng time para i-relate mo yung dalawa. Sa formulang ito, nakarelate na yung ating projectile motion. Okay? Isa pa, anong klaseng equation ito? Di ba sabi natin, na yung equation ng isang trajectory ay parabolic. Kung parabolic siya, so dapat parabola siya. So parabola ba ang equation na to? Yes. Yung x niya is quadratic at yung y niya is linear. Diba sa parabola, ang general equation ng parabola ay paano ba? Dito na ba? X plus h squared is equal to plus minus 4a y plus minus pala, minus k. Ayan. So, x is quadratic and then y is linear. So, kaya naging parabola yung ating trajectory. Kasi yung equation na to is parabolic. Okay? So, next meeting, we will try to be using that to solve equation faster. And then, don't forget your exam next week. Okay? So, any question?